So in this problem, we need to determine the equation of a parabola such that its vertex is at the origin and the directrix is given by the equation y equals to 2. Let us begin. So we'll try to understand the problem graphically first. So for this, we consider the coordinate axis. So here we have the x and the y axis. It's given here the vertex is at the origin. So this is going to be the vertex at the origin. So that means the coordinates are, the vertex will be 0, 0. And then we have the directrix at y equals to 2. That means we have a straight line which passes through the point y equals to 2. And we know any line which passes through the point y equals to 2 will be a line parallel to the x-axis. Now that we have the directrix and the coordinates of the vertex, we will try to specify the focus of this particular parabola. Now clearly from definition, the focus must lie on the negative x-axis. Now it's let's call it f with the coordinates x1, y1. Now the coordinates of the focus must be such that the distance of the vertex from the directrix lines must be equals to the distance of the vertex from the focus. So that's the definition of a parabola. Now, using these two information, how do we find out the coordinates of the focus? Now, clearly the focus is lying on the y-axis, which means the x-coordinate value will be 0. So that means x1 will be 0. Now, what about the value of y1? Now, let's try to figure out analytically the coordinate, the y-coordinate of the focus f. Now, if the directrix line is intersecting the y-axis at point A, then the coordinates of point A will be the x-coordinate is going to be 0 and the y-coordinate is going to be the distance of the point A from the origin. So that's 2 units. So that means the coordinates of point A will be 0, 2. Fine. So let's keep it y1 for the time being. Now we can use the midpoint formula to find out the coordinates of f. Now since we can use the fact that O is the midpoint of, O is going to be the midpoint of AF, which means that coordinates of O, which is 0, 0, so that will be equivalent to the sum of the x coordinates of A and F, so that's 0 added to 0 divided by 2. And we take the sum of the y coordinate, so that's 2 plus y1 divided by 2. So we're taking the midpoint formula here, which will be equals to 0, 2 plus y1 over 2. And when we equate it, we can get that the x coordinate will be 0 that we have already specified. Now we can equate the y coordinates. So 2 plus y over 2 will be equals to 0, which means that y value will correspond to, that's actually y1. So y1 will correspond to negative 2. Also, we don't have to go through this particular procedure because if the point A is 2 units above the x-axis, then the focus will be 2 units below the origin or below the x-axis. From symmetry, we can easily say that this distance will be negative 2. Okay, now I wanted to show you analytically, it gives us the same result if we go the both ways. Now that we have the coordinates of the focus, which is 0, negative 2, let's write it down. So our focus f has the coordinates 0, negative 2. So now we have the equation of the directrix, we have the coordinates of the focus, we can easily find out the equation of the parabola. So to find out the equation of the parabola, what we'll do, we'll consider a general point P. So let's say a point P which has the coordinates h, k. But there is a particular way of choosing point P. P is actually the locus of the parabola. We're choosing point P in such a way such that if we find out the distance PF, that's exactly equals to the perpendicular distance of the point from the directrix line. Let us suppose that a perpendicular line meets the directrix line at point M. So by definition of a parabola, we can say that the length of PF must be equals to the length PM. Now PF, we can easily obtain the length by using the distance formula because we have the coordinates of the endpoints of P and F. So here we take the square root, underneath the square root we take the difference of the x coordinate, so that's h minus 0. We square this value and then add it to the difference of the y coordinate. So we'll take k minus negative 2, which will give us k plus 2, and then we square this value as well. This will be equals to the perpendicular distance PM. Now there's a formula for finding out the perpendicular distance of a point P from a straight line. So here what we'll do, we're going to rewrite the equation of the directrix line. So instead of using y equals to 2, we're going to rewrite it as 0 times x, because there is no x component present, plus 1 multiplied to y minus 2 equals to 0. So this is the equation of the directrix lines, but we are writing in the standard form, that is ax plus by plus c equals to 0. Now what we'll do, we'll take the absolute value. Now we will take a ratio inside the absolute value. We'll have to start with the coefficient of x. So that's 0 of the directrix line. That gets multiplied to the x coordinate of point P. So that's h. That will be added to coefficient of y of the directrix line. That's 1. 1 gets multiplied to the y coordinate of the point P. So that's k. Then we are going to add it to the constant term, that's negative 2. Divided by the square root of, now we have to take the sum of the squares of the coefficient of x and y. So 0 squared will be added to 1 square. Let's simplify this. We're going to get the square root of h squared plus, so k plus 2 whole square is going to give us k squared plus 4k plus 4. We've expanded k plus 2 whole squared. This will be equals to the absolute value of k minus 2 divided by 1. Now we're going to square both sides to get h squared plus k squared plus 4k plus 4. That will be equals to k minus 2 whole squared, or simply put, we have k squared minus 4k plus 4. So here we can cancel out 4 from both sides, k squared as well. So we're going to get h squared equals to, we're going to transpose 4k to the right hand side and combine with negative 4k to get negative 8k. Now finally what we'll do, we'll replace the value of h with x and the value of k with y, and that's going to give us x squared equals to negative 8y. And this is going to be the equation of the parabola whose vertex is at the origin, and the equation of the directrix given by y equals to 2. And if we sketch this particular parabola, this is going to have something of the form. So it has to pass through the point P because that's the locus of the parabola. Its vertex is going to be at the origin. Right. So this is going to be a downward facing parabola.